Hello everyone. Today we are going to solve this problem LeetCode 84, the hard level problem of LeetCode, so-called hard level problem. It's not that hard. Okay. Now, what is the problem and what does it ask from us? It's about the largest rectangle in histogram. That is about finding the maximum area or the area of largest rectangle possible in the histogram. So we are given with a heights array. That is an array. Okay, and we have to find the maximum area possible. Just for an example, let's say example one of this. We have 2, 1, 5, 6, 2, 3 as the histogram, and these numbers in this array represent the heights of each bar of this histogram. Okay, so what we have to do, we have to find the maximum area. So here we have this maximum area as 10. Now we'll see that how did we get 10 as the maximum area. Why not we like, what are the approaches we can solve this problem? What are the approaches we can get 10 only, right? How could we know in this complex in this large number of bars or large number of elements in heights, how did we know that it was 10? Or what approaches did we try and we found we filtered the maximum out of these areas? Okay, now we'll see the intuition. Okay, now suppose this is the snapshot, same snapshot I have taken, and we'll analyze that how to solve this. Okay, now we have this problem, and I have written their indices also. Okay, 0, 1, 2, 3, 4, 5. Okay, now we'll see. First element is 2, second is 1, but 1 is less than 2. Because 1 is less than 2, we will pop 2. Now after 1 we have 5, 6, again 2, right? But 2 is less than 6. So whenever we are getting a lesser element, we will pop the greater element. So what will pop? We will pop the elements more than 2. So what are the elements more than 2? 6, 5. But 1 is less than 2. So we have to leave 1 as it is. Okay. Now what? We have been left with 1, 2 and 3 in this array. But one more thing is there. Okay. What is that? We have popped these elements. But we have to we have some remaining elements, right? How do we address them? Okay, we have 0, 1, 2, 3, 4, 5 indices. When we popped 2, okay, when we popped this element 2, because we found a lesser element 1, we will remove this one, this index of this smaller element, and we will assign this index to this. Okay, secondly, when we got 2, we had to pop the values more than 2, means 6 and 5. So we have to remove these indices, and the last greatest element we have popped, that index we have to assign to this number we have got. Okay, so we are left with these numbers. That's it. Now what? Now we have to find the maximum area, right? So we had this as per the approach, we had this area, as the largest area, right? So this is the possibly the largest area or largest rectangle, we can say this. Okay, so now we'll see how did we find this. Each step we are doing, we are popping some element. Okay, because we are storing them as per like index and value. Okay, so let's see how to solve the problem. So initially we have max area. We'll go along with the drawing explanation. Max area will store 0. Okay, and we will for storing some pair, we'll use stack, simply some empty stack. Okay, now we will go in heights. How we'll go? For index comma each height in this array given as heights. Okay, I'm sorry for the spellings. Okay, but how we'll get I and h? We will enumerate this. Okay, so let's enumerate this. Okay, now we have this. We will just start with the current. Every time we'll start with index that we are iterating on. Okay, here we'll start. Initially it was 0, right? It was 0. It was 1, 2, 3, 4, 5 indices. So along with the index we will start. Okay, every time whenever suppose a stack is empty, in our stack nothing is there, right? Initially nothing is there. So what we'll do, stack dot I'm sorry, stack dot append. What will append? The pair at which we will start. Okay, and will append with along with the height. Okay, now this we did. Why? Because our stack was empty. But why? But what if our stack is not empty? What about the second iteration? Okay, so while stack is not empty, while stack is not empty, and the second element by which I want to say that the element which is this element 6 is more than 2. How did we know? We are storing every element in stack, right? Enumerate of heights means 0 as index, 2 as height, 0 comma 2, 1 comma 1, 2 comma 5, 3 comma 6, 4 comma 2, and 5 comma 3. So that is how we are we are doing, that is what we are getting after enumerating the heights. Okay, now we are storing every pair in this start in this stack. Okay, in this stack. Okay, so what does it store? Index comma height in heights. Okay, this will store. So while stack का कौन सा height? Stack of -1 means last से देख रहे हैं, we are saying from last, and the second means index 1 means the second one element we are saying, while this one is more than the height we have. Okay, while this loop goes on. Okay, while loop until we get a smaller element. This means that until we are getting a smaller means this is in the stack, this should be more than the current element. Okay, then what we will do, we have seen that we will pop all the elements which are more than the current elements. Okay, how? Not pop, this will do. Okay, and let's store, I think let's store as idx comma val, index comma value, we store like this. Okay, now uh, just recall what I said. The second step after popping this, we have to find the area, right? That's why we have make this variable, we have made this variable max area, right? So let's find the area now. So we have to find the maximum area, so we'll use max function, max area comma, how to find the area? Because we have current index here, right? This is our current index. Suppose this was our current index, this was some index, so we have to find this area, right? So how would we find this area? In this minus this means this much of width and this much of height. 5 into 10, 5 into 2 is 10, right? 5 multiplied by 5 is the height, and what is the width? This width means this index minus this index, right? So that will do. That's how we'll find the area, right? So height multiplied by width. What is width? The current index, the index we are going on, minus the index we have pumped, right? Idx, that will be smaller than the current index, right? So what was our next step? The first step we did was to pop it, and the second step we have completed the area, right? What was the third step? We will assign this index to the index of the popped element to the current element. Okay, like we had index 2, right? We have assigned it to 2. This element 2 we have assigned, right? The index of this element we will assign to current element. The popped element, the largest popped element, will assign to current element. Okay, now we'll assign, let's start from idx, we have assigned it. Okay, now what? Now it's okay. Now see, we have been left with 1, 2, and 3, right? Then what to do of them? They might give, right? They might give some area which would be greater than our max area we have found, right? So again we have to use a for loop to to eliminate this problem, right? So to eliminate this problem, what we'll do to eliminate the problem, we will go like for index comma height in stack we have made. Okay, in stack, okay, we'll find the max area is equal to maximum of itself, comma, okay, we'll find like the last one, we'll find the area. Okay, index approach, we'll take the length of heights minus I, that's it. That will give us the maximum area, right? Now we will return the max area. That is something we have to return. That is something which was our final answer. Okay, now we will run the code. Okay, so I am sorry for this. I think I have some spelling mistakes from my side. I'll just make this heights, and here I had to use a value. Oh, right. Okay. Okay, so I think now it's okay. So let's run the code. Okay, so it's accepted. It's okay. Now we'll submit this. That's all the solution. It's pretty some optimal solution. Okay, thank you very much for this. You can post your comments, and if you have any doubts, you can ask in the comment section, and you can mail me also. Thank you very much. Thank you.